Thank you for joining the Once Changing the World, India's first future tech meets sustainability podcast. And today I'm delighted and honored to have with me Dr. Babu Padmanabhan, an engineer, entrepreneur, researcher, author, founder, MD, and Chief Knowledge Officer at Steer World. Dr. Babu is leading the charge in waste management with a groundbreaking product called Unwood. Unwood utilizes waste and discarded plastics to create a sustainable alternative to wood, a game changer for our environment. Topic of discussion today is going to be sustainability and reimagining recycling. So Dr. Babu, really appreciate and truly honored to have you on our podcast. I think it'll be great if you can start with a brief intro and background.
Sure thing, Eddie. Firstly, thank you so very much for having me in the show. I know that you're instrumental in breaking this information asymmetry in the world, bringing information that is valuable. So I'm truly grateful for the opportunity. A quick introduction would be that I'm an analytical kinematician. So the field of kinematics deals with things that move. A very good example of a kinematician would be the Greek mathematician, the Greek physicist, Archimedes. He came up with this concept of simple machines, the lever, the inclined plane, the wedge, the screw, and notably the pulley. In fact, people would remember this quote that give me a place to stand and I can, move the moon. And he actually demonstrated by, pulling ships single-handedly to the shore. So he understood how forces can be deployed to make work happen. So kinematicians deal with this. Energy is there. How do you create work? But then a lot of what kinematicians do is to do with geometry. And aspects of geometry has been around for much longer. And geometry is the foundation for it is mathematics. I still today, to this day, when I introduce formally, I'm expected to say that I belong to the school of Apasthamba. And if you ask me, Eddie, who's Apasthamba? He was an Indian mathematician, Indian sage, going back 2,500 years ago. Somewhere between the Godavari and the Krishna is where his seat was, it's expected. He belonged to this heritage of Baudhayana, an Indian mathematician, geometer. They were one of the first to square a circle. The problem of squaring a circle involves finding square roots. And his ability to find the square root of 2,500 years ago to the fifth decimal place is still, legendary. So I belong to this school comprising of mathematicians, kinematicians, and notable kinematicians would be, apart from Archimedes, René Descartes, who brought the Cartesian coordinate system. We know how to even reference something from that. Isaac Newton, the laws of mechanics, legendary, a legend in that sense, and so forth. So I belong to the school, and therefore, when it comes to utilizing machines to transform materials, it kind of plays into that ability.
Thank you, Doctor, for kind of explaining your background and your influences, your background in mathematics and Apasthamba. I mean, something which I just got to know about it and was Greek to Apasthamba, but thank you for bringing this to my knowledge. Yes, so I think maths is so core to every little thing, because there's this Max Tegmark, a professor at MIT. He's written a book on how the entire universe is mathematical. So I think, taking mathematics and creating innovation is such a core balance. Global warming, today I think we're seeing extreme weathers, we're seeing heat waves, and the big four emitters in the world seems to be China, US, India, and Europe. 2024 is the hottest year. There was UN, which kind of declared code red. There was climate scientist who wrote a petition on how urgent this global warming is, and I think even recently, I think a couple of scientists who kind of wrote publicly that we have pushed the limit. So there's all this talk about climate urgency, but somehow I feel that the urgency is not there at all, when these nations are talking about global warming. There is obviously, I'm not going to go to other nations. I'm talking about India itself. India's net zero goal is 2070. So what are your thoughts on global warming? How dire and urgent is this problem? I think it'll be great if you could address that.
Well, it is a kind of a poignant question because it connects with me at various levels. I have myself worked in the space program. When I was a student in the US, my projects all were to do with the International Space Station. So going extraterrestrial, inhabit Mars or the moon or beyond the planets. Is that the plan A for mankind? Let's not worry about Earth and find ourselves another home. And therefore, you do everything with silicon intelligence somewhere or the other. It is a very powerful question to contemplate ourselves. But if you think about what has happened, 250 years of industrial revolution, post the invention of the internal combustion engine to use for power transmission, electrical power later on, a few years later. I'm talking about 1860, when the first internal combustion engine is born. And if you see from that point of view, the amount of carbon dioxide in the air, and of course other gases, including methane and others, has really become substantial. India's share cumulatively over the last 250 years is only 3%. So pretty much 1/6 of the world's population, 3% of its emissions. So we have been at 5th of the total emission. So if at all any nation, any society did service to Mother Earth, you are in that society, Eddie. So can we keep it there that whatever we do in this particular era of ensuring our citizens, and we are part of the global South, we can provide our society, our children, with the kind of living, the quality of life, kind of living standards that they truly deserve. So which means you have to provide for things. But at the same time, you can keep ourselves at that, emission levels. I think that's the program that we can see kind of unfolding in this country. And every person has a little something to do, in this particular endeavor. And the way I have positioned, Steer and the company that I've founded is, whenever we have produced it like a process, even automotive, when it went from assembling at one station, all of them come to make a car or a vehicle, to a production line, an assembly line. You can see whenever we kept anything in movement, then the efficiencies really improved. So what we're doing in the process industry, Eddie, is to create a similar effect. When we keep things moving and work on it, then the efficiencies change dramatically. And that's what we are doing in the pharmaceutical industry, food industry, and other process industries, polymer industry, to be able to bring down energy consumption to its true enthalpy value. If you use the word physics term called enthalpy, what is enthalpy? The exact amount of heat input or energy, heat and energy interchangeable, required to do your work, whatever work you've envisaged to do. If there are no losses, that total quantum of energy or heat that is required to do that is the enthalpy. So can we work at enthalpy values to do the transformation? So those are the kind of challenges we have undertaken. So now the question that you asked is, of course, far greater. What is humanity doing? What are nations doing? What's going on at the various COP meetings and so forth? So clearly awareness has come about, and even this podcast is all about continuing that particular conversation to remove or reduce the information asymmetry that's happening in the world, and the information which is there to make sure that it is, first of all, understandable, but more importantly, it's valid. It's not a doubtful information. It's not, hunch or somebody's guess, but it's actually scientifically validated type of an information. And that's the kind of dialogue we want to get into.
To your point that, plan B seems to be, creating silicon life, moving out to Mars. I think, humanity need to take a pause and understand that all that sounds good, but the only thing that we have is this beautiful planet in this entire expanse of darkness. So I hope that we kind of find ways where you mentioned, reducing our energy consumption through these enthalpy methods. Finding ways where we consume and become more economically independent, because yes, I think India is a growing economy, and it should, the good of what we have developed should be equitable, and I hope that does. But I think while we are consuming, I think there should also be a thought given to conservation. There should be a conscious effort to kind of find ways where we transition from coal to possibly clean energy, solar energy. Also move our mobility industry from maybe ICE to EVs. These are, I think, steps if we consciously kind of effort, and there's a larger narrative by even the government. I think we'll take one step towards finding a way to not cross past that 1.5C target, because the world's top climate scientist expects the global heating to pass that 1.5C target in 2024, and somehow I don't see a constructive approach. I see a lot of conversations, but I think we have passed the point where we have conversations. We need actions, because yes, I think, we live in a world which is so diverse. Everybody has a certain point of view given a certain geography that they live in. But our world is so interconnected that what happens at one place impacts the entire world. And I hope that we open up our eyes and realize that that's what's happening. Would you also share your thoughts on, the growing menace of plastic pollutions? Because that's a huge problem. I lived my life all my life in Bombay. I was for 50 years in Bombay. The last 2 years I moved out of Goa, because the reason I moved out of Bombay is because I feel that like a house. I'm just going to give an analogy. My in Bombay, I lived in a 1 BHK small house. We had 3 people living over there, me, my wife, and my child. And I think every space has a carrying capacity. So my house 1 BHK was great. I loved my 1 BHK, loved it. But imagine if that 1 BHK is pushed with 50 people, 100 people. It's not going to hold that, right? I think the same way Earth has a carrying capacity. And I guess we are 8 billion, and yes, I'm sure if we find ways, like you mentioned, like reduce energy consumption, find other ways to kind of co-live together where we consume and conserve, I think we will go to a future which is sustainable. Are we going towards a sustainable future with this growing menace of plastic, where the cows in the street are eating plastic, the fish has got plastic, landfill has plastic, oceans have got plastic? Would love to hear your thoughts on that.
So the gravity of the situation, that something is truly amiss. We can't just maintain status quo, business as usual, and expect that, some divine hand will come and bless us. That's clearly not the way. it's going to happen, that we have to heal ourselves. We have to heal the planet. We have to heal the people too. And some of the aspects of what it is to have thoughtful consumption, what it's to have more conscious capitalism, a lot of work going on. How soon it will reflect in the way we see the world itself, that is emerging. I have great optimism for it. And sooner than later, we'd see a world where people have become more conscious about realities of the world, more thoughtful about what they're actually doing, and so forth. But talking about pollution, it's a very, very interesting and important topic. Let's take two very simple molecules. The first one I would take is glucose. We absolutely need glucose to survive. The brain, devoid of glucose, will shut down very, very quickly. Now that, if it becomes 200 milligrams per deciliter or 2 grams, we are in great trouble. Great trouble. What happens is the glucose starts reacting with amino acids, reacting even with hemoglobin in our bloodstream, and creates what are called glycated products. And what we are measuring, long-term effect of it, is a molecule called HbA1c, which is a glycated hemoglobin. And we can actually measure, saying if somebody has been having elevated blood glucose level, the resultant product is a glycated hemoglobin. And by measuring the levels of that, you can actually tell that the person is suffering from higher glucose levels in the body. And it starts actually damaging organs. Eyes get affected. It ages pancreas, it ages kidneys. Just that little difference. The body needs only a gram per liter of glucose, and change that, we are in trouble. Now, we keep putting all kinds of substances into the soil, into our water. And if we don't have control over it, if we don't have a thought about it, what we are putting, then we are in trouble, whether it's called a fertilizer like urea, whether it's lead, which we started putting into the atmosphere because of leaded gasoline. No matter what it is, whether it's a radioactive material, no matter what it is, something that is getting into the environment beyond its tolerance level, we are going to be in trouble. It is going to cause a toxic effect on the ecosystem. And the earth is an ecosystem. It's alive. It's not just human beings are alive. The entire earth is a system. And now the point you're asking me is, how do we deal with a material like plastic? It's an organic molecule. What does that mean? It's a carbon form, a carbon-based molecules. But that material starts becoming smaller and smaller and becomes a substance that can infiltrate our biome, including permeate through our cell, or just be in an environment, a biome, where it can cause this level of toxicity. I can get into technicalities, Eddie, in terms of why an hydrophobic molecule can attract fat-like substances, and therefore, when it's laden with all other inorganics, including certain toxic materials like arsenic or lead or whatever, such a molecule, which is otherwise inert, can become a very powerful destructive force. And these people generally, although it's a misnomer, really, microplastics does not mean it's only all of the plastics we use become microplastic. Debris of any kind, rubber debris from tire use. So, general term we have come to use is that a substance that's becoming smaller, that's of carbon form, a carbon molecule, has the destructive ability, and we have to be mindful. And this, over the last 100 years, is a significant advancement in thought process, because it's only the last 100 years, Eddie, this advancement in materials happened. Now, if it not happened, the earth would have been a much more difficult place to live. If we had continued to use ceramics, steel, or paper, or any other kind of fiber to do what we do as living beings, human beings, the earth would be in a lot worse shape. We have conserved energy, we have conserved resources by doing what we have done in terms of advancing materials. But we have realized that one aspect that we have to be very mindful of is we cannot leave these materials lying around in places where it's not supposed to be. It is true even when we open up our bodies for a surgery, we can't end up leaving anything inside our abdomens. We just can't. So it's the same thing. What is meant to be in my office cannot be on earth or water. It's ridiculous to just imagine that you could spread all of just like how precious our own body is. If a surgeon has to cut open and do something, they can't afford to leave some suture behind or, their cotton behind or, our body won't tolerate. Earth cannot tolerate materials or substances in the soil, in the water. It's not meant to be there.
Yeah, so I think, I do agree that humanity is prospered because of the understanding of the advancements of, how do you design new materials. But somehow I think, what we have maybe we just didn't have the bandwidth to kind of understand, look into how nature creates design over there. Somehow it's a complete circular economy kind of a thing. It's whatever designs that we've created, innovations that we've created, we solve one problem, but it creates a couple of more other problems. While nature, does it so beautifully, I hope that we kind of find a way where we understand how deeply and awesomely nature works and build and innovate like how nature does. Will be great if you could talk about Steer World, the vision, its mission, and also Unwood, the product that you guys are building.
I think you're right. Nature has this amazing ability to follow cycles. And whether it's the energy cycle, the carbon cycle, nitrogen cycle, water cycle, that how nature is able to maintain the entire system stable is something very special, and we need to understand this. But what is this invention that you want me to talk about? Is an invention that leads to being able to capture polymers or plastics that we know we don't have the ability to separate. So polymers fall to various categories. And just for a minute, I want to help everyone listening to it have an idea. Starch is also a polymer. Our skin is a polymer. Our protein is a polymer. And the word polymer is used for anything which is a long chain of molecules with repeating units. So same unit repeating. Starch is a polymer of glucose. So is cellulose, which is very common in cotton. So starch, cellulose are all polymers of glucose. So similarly, we can make polymers where just carbon chains sit all over the place with hydrogen all around them. That is called polyethylene. Similarly, depending on the arrangement, we use different terms for polypropylene, family of polyolefins. Polyesters have some oxygen in it. Amides have some nitrogen in it, like that. So there is hundreds of these different types of polymers. What mankind has found out is when we try to do effective packaging, which results in food security in the country, especially a country like ours, where you have to provide for our citizens, then combinations of layers and layers of different materials enhance affordable packaging. But now comes a condition that what do you do with this combined material? It's got so many layers. You can even put a metal layer, aluminum layer, so that the best barrier property, the best protection for your Lay's potato chips, or no matter what the brand is, you can get. But then what do you do with this material? Does it go into a landfill? Does it get incinerated, enter the ocean? So we needed a very spectacular technology, how to nanonize these molecules, have them interact at a molecular level so that without the need of more toxic or any other kind of compatibilizers or anything. The interaction between these molecules at a nanomolecular level can be achieved. And therefore, a new material, a new alloy forms that can actually be extremely useful. And that's the power of technology. So using that, it's the same principle like how wood is formed, or steel reinforced concrete buildings are made, that there is reinforcement, the fibers are formed, and these fibers can then help build the material itself. I got too technically already, I'm sorry about that. But clearly, following how nature works with these molecules and understanding these, you can actually still use a very difficult material, make it a resource. So what does nature do? And this is a point you were making very correctly. In terms of nature, that after a process is finished, that becomes a useful resource. Even a dung beetle will come and do something with it. So anytime a process is finished, the next becomes the raw material for next stage. So it's flows. So now we have a solution to all these important packaging materials that creates food security, that creates health and hygiene, all our masks and a COVID type of a problem occurs in the world, then we need protection. And what do we do with these materials? So we can convert them into a wood-like material. So currently, several million hectares of forest we lose because we need material construction. So if this can become a wood-like material, as good as wood, the first time in the world, we can create an affordable material. Wood has been hard to replace, not just because of its property. It's an amazing natural material. The kind of stiffness we get for its weight is really hard to replicate with all of the modern materials we have. And it's so affordable. For that kind of a price range, can we build a material as good, if not better than wood? That is the problem that had to be solved so that we can solve two things, pollution as well as deforestation.
Right. Dr. Babu, can you kind of elaborate on this a little more? Because I think it sounds like you kind of completely reimagining recycling, taking plastics and creating this form of wood, which you're calling it unwood. Talking about replacing wood, that means, creating something which kind of would completely be groundbreaking and revolutionary, because you rightfully pointed out, it'll take away the deforestation and the entire, and how you're using it, building it is through these plastics, waste. So maybe talk a little bit, elaborate more about this. When this really becomes a finished product, has it become a finished product? Is it gone to the market? If it's gone to the market, who are the ones who are using it? What's been the market response? And yes, I think will be great if you can elaborate on that.
So over the last 30 years, it took phases of growth. So first 20 years was devoted to creating the hardware. So it's almost like if you say somebody imagine the smartphone, and it didn't exist, and it take years to build the smartphone itself. And it did happen, phones went through evolution until it became a smartphone. So similarly, we had to build the hardware. That took 20 years of time. 1993, the company is born. By 2012, 13, we knew roughly where the smartphone. But the smartphone is only as good as what it runs. It needs an operating system. It needs applications. So for the last 10 years, we've been totally focused on figuring out, now that we have this smart processor, now, how can we use it intelligently? And by 2016, 2017, that's about 6-7 years ago, we realized we could do intelligent compounding, which is that we can efficiently combine materials, completely transforming its functionality and properties in pharmaceuticals, in plastics, and food. And then over the last 5 years, we've been figuring out what is the fundamental problem we need to solve in the world, whether it's in nutrition, whether it's in medication, whether it's in fighting some of these urgent climate matters, including pollution. So now that we understood how to do intelligent compounding, nano compounding, molecular interactions, and so forth, we took on a few problems. And one of which is we have these 4 billion kgs, 4 million metric tons of plastic waste out of almost 11, 12 in this country, in our country, versus almost 100 million metric tons in the world, is a total amount of these wrappers, sachets, plastic film type of waste stream, which is not getting captured properly. It gets incinerated, it goes into landfills. So we realized that is the significant problem. And the problem is intelligently using this material. So we started figuring out. So last 2-3 years, we found that we can actually compare it with wood-like properties at a cost compared to conventional wood material. So now we have done pilots. We sent 10 tons of this material to Kenya because the Kenyan government, United Nations Environment Program, UNEP, is headquartered in Kenya in Nairobi. So very conscious about saving forests, preserving the environment. So one of our first supply that happened last year was to Kenya. We sent 10 tons of our wood substitutes to Kenya. Since that time, to go from an incubation to commercialization, that's a phase we are in, Eddie. So we have been carefully navigating through this in terms of building it. Now that we have built it, so we are more visible, meaning all these years it was quiet work because we had to actually, put our heads down kind of and build it.
Right.
And everyone would want proof of concept, credibility. Are you really walking the talk? Is this even real? What are the challenges? Will it even cause more problems? Like you said, over 250 years, what you see is one solution creating more problems than actually fixing, right?
Right.
That is the history we have to, contend with. You have to be aware that, is this really a solution or are you just creating more problems?
No. So wish you and your team the very best. And I guess, as humans, we have to forever kind of, find ways to solve a certain problem. And the quest of doing that leads to, solutions. Maybe, I'm sure we will possibly go into a point in time where we create, solve a problem. And then there is, we don't create another problem, while fixing that thing. So yes, my question is, do you see this replacing wood? Because you said the cost of it is now comparable to like the conventional wood. Would the cost come down of your product Unwood? Would it replace wood in the near future? Like, are the chances that it could possibly replace wood? And how do you see the role of policymakers, governments? Are there incentives in place to kind of make sure that this narrative goes out globally and there's more adoption of this?
So yes, this is a material that is going to be as affordable as wood, but having some features or properties that are better because it's more durable in that matter. It's coming from a polymer that's quite durable. So we are concerning ourselves with how to build this ecosystem. We're inspired by Amul. So Amul built an ecosystem ensuring quality of deployment. So when you deal with a variety of input material, milk from every cow may have a different fat level. It has so much of variability. We don't know whether the farmer by mistake gave it some, tests. I don't know. So you have to be really concerned with the quality of the output. And because there's so much variability in the input, it becomes even more important to ensure that the material is truly inert. It's going to be used right. It's not going to create another problem that we just proliferated. Next, it generates even more microplastics. You can't retrieve it back. If we can recycle this material. So you need to know that the material can truly come back to you if necessary and so forth. So clearly we want to build a very large revolution, kind of like a brown revolution. We had this amazing green revolution, white revolution in the country. A movement, actually, maybe we can call it a brown movement. and therefore a lot of responsibility on our shoulders, you can imagine. Yes, indeed, I think from a global level, whether it's the World Economic Forum, United Nations, various other agencies there, and the government itself. But there are milestones to achieve, Eddie. Nothing is going to happen until we have crossed in very clear aspects of deployment. And that's the program we're running. We see it's in a very conducive environment. People are receptive. They're waiting and watching to make sure that we walk the talk, that this is real, that we can deliver. For instance, we can actually build 1,000 hubs that will collect all of this 4 million metric tons of waste stream that even happens in our nation, and convert it to wood-like material that can become school furniture, that can become various kinds of cladding, whatever we deploy wood for. And that much of savings of wood is going to be really, really important for our country. But then we can walk the talk and we'll deliver on it. So certifications, validations. So government is very simple. The question is, has it been validated? Which is the agency that is given, approvals or whatever. So we need to go through the works. And after that, it accelerates. So that's the process we are in.
Is there any advice to, businesses or individuals, to how do they go about living a sustainable life, in this current situation where we are global warming is screaming at us. What's your advice to, support a circular economy, in their daily lives and businesses?
Well, that is a very important question to ask ourselves. I work with the World Resources Institute, and they're promoting, can we walk? Can we bike? And how are we looking at what we consume, how much electricity we use, how much water we use. So I think just becoming aware that what we do individually, and a lot of school ads today talk about the children asking these questions already. It's what we teach the children. They become conscious of what they consume and what waste they generate. I think just becoming extremely aware that what we're consuming and what waste we're generating. And are we doing something about it? If it's organic waste, are we making sure it becomes soil again? Are we making sure that it is not just thrown away somewhere? We will make conscious effort to see that it becomes another product. These are very simple questions to ask ourselves, and then this creates a movement.
Right. I think life is so simple at times. It's us humans. We always complicate things because we like things complicated. We don't like things which are simple. I hope we stick to our simplicity and one step at a time, do the simple things, and everything will unravel by itself. What's your personal moonshot, and what's the future that you envision for yourself and Steve World?
Actually, when you started talking about complex or complicated, the difference I wanted to imagine as a mathematician. So we do have real numbers, imaginary numbers, and what we call as a complex number is a number that has a real component and an imaginary component. That's complex. So yes, life is complex because we have to imagine the future. So life is complex. But when does it get complicated? I was imagining this as you were thinking, why is it simple and why is it complicated? So complicated is knowing something is going to go wrong in the future, we still go ahead and do it. So clearly, only when it gets complicated is despite our knowledge of the future, we get into these difficulties. So anyway, we'll park that area for a future philosophical discussion with you face to face. But coming to, what our vision is or envisages as moonshot, healthy mind. We absolutely need a healthy mind to have a healthy planet. And for us, to look at various problems, including addiction. People are, why are we addicted to chemical substances, whether it's alcohol, whether it's nicotine, and there's so many families of chemical substances people get addicted to. It's because of our brain constantly looks for stimulation. And of course, the brain is capable of getting stimulated. We have dopamine, oxytocin, 100 neurotransmitters, including endocannabinoids. You don't have to take cannabis-based substances to, have that kind of stimulation. But we take external substances, and a lot of it becomes addiction. So our moonshot program, thought process, or vision for the world would be, can we really rid the world of addiction and pollution at the same time? And just build a healthy mind, a healthy people. In fact, the word healthy is heal, die. It's hidden there. It's heal yourself. Healthy. You're responsible. Heal, die. Be conscious that you can heal yourself.
Doctor, really, really appreciate you taking time and being part of the podcast. I think a profound note to end this beautiful conversation. Heal thyself and you'll heal the environment, the surrounding, and you'll heal the world. I think we are in such a beautiful point of time in human history. I think the world has been given information free of cost and knowledge almost free of cost because of internet technology and these things called MOOCs, massive open online courses, where the entire knowledge repository is available online on the internet, and it's for free. And that's the most beautiful thing. I think the only thing that is stopping someone from creating a better future for himself or his family is the desire and intent, because everything is available free at this point of time. And that's the way I think the world was created. If you see the world, it's got everything, and everything was free. Energy free, food free, water free, air free. Then comes in institutions where we bring in capitalism. And I think we are racing towards nowhere, because we've gone to a point where our self-preservation has like kicked into a play where everything else becomes invisible. And I think the world is so beautiful and is so interconnected. I hope people open up their eyes and understand that what happens over here, impacts the entire world. And I hope that we become one. I think so far, religion, politics, institutions, education, healthcare, it's so divisive. It kind of divides you, because you got the money, you get into my college. You are Catholic, you come into my church. You are Parsi or Muslim, you walk into my space. I think we need to let go. We need to learn to give, because I guess that's the way we'll become better as a race, because we've got a beautiful opportunity to join hands. Because who would have thought, even 15 years ago, that we could converse with anybody in the world? Because like Mark Zuckerberg, who the world loves to hate, he's the one who's created magic through these social media platforms. Yes, there is nothing good and bad. There won't be anything which will be completely good or completely bad. Like the yin and yang, good and bad needs to coexist. And I guess that's the way it is. I only feel let go and let be. I keep on saying life is very, very simple. And more power to people such as yourself who are creating these innovation and finding ways to solve problems and create a better world. So I wish to see Unwood. I wish to see Unwood, taking over at the wood completely, because what a beautiful world that would be. It gives me goosebumps just to imagine a world, no deforestation, no plastics. More power to you, more power to Steve World. And to my listeners, if you like what you see in here, then please press the subscribe button. Until next time, see you guys. Bye-bye. Thank you. Thank you, Doctor. Really appreciate this.
Thank you so much, Eddie. Pleasure talking to you.
Thank you.